is one more thing before we go into acceleration. We're going to discuss speed. What is speed? Speed is how fast something moves. I hope you all agree with that. And now with all this quantitative mathematics horrible stuff, what exactly is speed? First of all, speed may look different according to different people. You are in a highway, you look very fast compared to other people, but you look slow for the car behind you trying to pass you. So it is something for a specific frame, and it differs from frame to frame. It is not frame dependent, so sadly we cannot use that to construct our physics law, but it is still useful. We talk about speed all the time. So what exactly describes how fast you move? Is it Vx? Kind of. We know Vx will move you. It will change your x position. But you can have something moving fast with no Vx, like the ball in the boy's frame. In the boy's frame, the ball is moving, the ball is going up, but relative to the ball has no x velocity. However, the ball is moving, so it must be somewhat fast. It shouldn't be having no fast. The x velocity of the ball is 0, even though it's moving in the y direction. So we know just by the x velocity itself is not speed. Similarly, it's also not going to be just dy. So we should have some combination of them that as long as the thing is moving, you have a non-zero speed. The easiest way to do that is to square them, add them together, and take the square root. That is what speed is. So if you look at the thing, you see that it is always bigger than 0 because it is a square root. It will be fine because you have the square root of Vx and Vy. Vx can be positive or negative depending on if your x position is increasing or decreasing, you're moving left or right. Vy can be positive or negative depending on if you're going up or down. But the square root of them will always be positive. The square root of a plus or negative number will always be a positive number. And then you can have a positive number for sure in your square root. So you don't have imaginary speed. And this will be non-zero as long as one of them is positive or negative. As long as something's moving, this will be non-zero. So far so good. And to make sure this is speed, we again do the simplest case, which both of them, Vx and Vy, is constant. So if they are constant, then a thing on the xy plane is just the frame you just imposed. So whatever the thing is doing, it is actually doing that. If it's going right, it's going right. If it's going left, it's going left. Now, if they are having constant Vx and Vy, then the amount that goes to the positive x is just the x velocity times how much time has passed, if the x velocity is constant. Alright? But it is the change of x position, so that will change the x position. However, if the object has y velocity at the same time, the y position will also change by dy delta t. So at the end of the day, after delta t, the object should move from here to here. This diagonal distance, that's called s, is the distance that the object actually travels. Is this correct? TRNBE LED? Okay, good. looks weird for some reason. Alright, so if the thing is moving with constant Vx and Vy, after some time, it will go to this point, following this diagonal line, and it will move for a distance d. Distance should be related to how fast something moves. If I say I go to somewhere 20 miles away within 1 hour, that's not fast. I go to Los Angeles within 1 hour, then that's very fast. And some other guy also go to Los Angeles, which is equally far, but it took him 7 hours. That's still fast. It took him 2 days. Then you see that even though you move very fast, very far, it doesn't mean you move fast. You are moving fast only if you move far within a short time. So what matters should be the distance divided by how long or how many time it takes you to move that distance. It should be the ratio of increasing or moving in terms of how long distance you have moved. That should be what speed is. Any, yeah?
Is it possible for velocity to be negative?
So, first of all, sorry, what's your name?
Joseph.
Joseph, okay, so for x or y velocity, they are defined by how your x and y position change. If your x position change from 2 to 1, then the change of your x position is from 2 to 1. You end up at 1, 2, your x position decreased by 1, and in this case, the x velocity will be negative. Any other question? Alright, good. But speed should be positive as long as you're moving, because it's just how fast you're moving. It doesn't care about direction. So that's why we square it and do this. But we should have a simpler definition, which is just the distance that you travel divided by how long you take. Now, you guys learned Pythagoras theorem? Okay, so if this is x, y, this is parallel, this should be 90 degrees. So according to Pythagoras theorem, this should be the sum of the square of these two. So this will be square root Vx delta t squared dy delta t squared divided by delta t. Now, when you have delta t in the denominator and you move it inside the square root, a t in the denominator is equal to 2t inside the square root. Does that make sense? Let me do it slower. So, first term is delta x times t, the whole thing squared. The second one is Vy times delta t, the whole thing squared. So, first I'm going to get rid of the parentheses. Parentheses is the enemy. So, a whole thing squared is everything inside the parentheses square multiplied by each other. So this is what the thing looks like. I still need to keep a parentheses because otherwise it looks like the change of t squared, not the change of t and n squared. Okay? So you see both of these two terms as delta t, and then you can combine them into just delta t squared times Vx squared plus Vy squared. And I hope now if I extend the square root, you are agree that I need to add a square here. And then you can cancel, and then this is what speed is. So indeed, speed is Vx squared plus Vy squared, square root. Okay? Now, this is for constant Vx and constant Vy. What if they are changing? Well, you just cut your time interval again short enough such that in the interval you concern, the velocity looks like they are constant. And no matter what, this will always be the ratio of the small distance you move in a small time interval, and the ratio should always measure this. Should always measure how fast you are moving, no matter you move a long time or a short time, long distance, short distance. As long as the ratio is big, you are fast at that time. And you can tell that because we can have dx and dy at a specific time instant, we can have velocity at any specific time instant. This is also a function of time. You can have a speed just by a given time. That is exactly what your speedometer on the car is telling you. It is telling your car, it's telling you how fast your car is moving at that instant, and it's telling you the speed. You only see one needle going because there's only one number. It cannot tell you which direction you're going. It's not a GPS, it's just going to tell you how fast you are moving. So that speed, yeah, so direction, it tells you how fast it is. It can be related like this. And it's a function of time. Any question? All right, let me try to adjust the camera so I can